Thanks for having me. So, as the introduction said, I'm wearing two hats today. So, I'm both an academic with Harvard at the Institute for Quantitative Social Science, but I'm also sort of branching out into sort of real-world applications. And we do have a startup called Thresher, which hopefully, if I have time, I'll talk a little bit about what we do. But so first of all, today I'm going to talk about text analytics, right? So, what is text analytics really? So here's the Wikipedia definition, right? So it's a set of linguistic, statistical, and machine learning techniques that model and structure the information content of textual sources for business intelligence, exploratory data analysis, research, or investigation. So it's a very, very broad set of things, right? So what is it really? This is what it really is. Basically, we're going to take all your social media, all your documents, anything that really has text in it, and we're going to turn it into some type of knowledge that will help us in the real world, right? So what do we mean? What are some of these common methods, right? So generally, you'll hear of two general areas of methods, and they're not necessarily independent. But the first one is sort of natural language processing, right? So what is this? So basically, if you have a document or if you have a text, you need the computer to read it, right? So things like, if I have a sentence, tell me what is a noun and what is a verb, right? How do we figure that out? And that's a huge field in computer science called NLP. And then we have sort of machine learning, which maybe a lot of you have heard of before, right? So this is sort of looking at, in the text context, this is looking at a lot of documents, and we're going to sort of group them, we're going to classify stuff, we're going to predict stuff, right? So the most basic machine learning is sort of spam and no spam, right? So if you have an email, how does the computer figure out whether it's spam or not spam? And that's machine learning methods. So what are some applications of these two groups of methods, right? So I'm going to introduce this paper. So this is one of the first papers really to do text analysis. This is probably one of the canonical examples, and I found this interesting when I first learned about it. So this is Mosteller and Wallace in 1963, and these are two statisticians. Mosteller was the chair of the Harvard Statistics Department at the time. So maybe if you remember from your American history class, so the Federalist Papers, it's a group of, it's a bunch of papers published in newspapers, written under a pseudonym, and basically this was written in 1787 to try to persuade people to ratify the Constitution. Right? So, as I said, it was anonymous, but people started to figure it out who wrote these, and so they figured out that there were three authors, right? So Alexander Hamilton, James Madison, and John Jay, and sort of eventually we kind of knew who wrote how many papers. It just came out. So we know that Hamilton wrote at least 43 of them, Madison wrote 14, and John Jay wrote 5 of them. But there are 12 papers that are kind of disputed, right? So what happened was Alexander Hamilton died. He was killed by Aaron Burr. And right before he died, he had a list of all the papers that he wrote that sort of he gave to his lawyer. And when he died, that list was revealed. And that list had a lot of papers in it. And people were thinking, like, that's not like, we don't think he wrote all of those. He's just trying to claim credit, right? And so people actually thought that Madison wrote some of the ones that Hamilton claimed. But Madison at the time was sort of still a politician, and he eventually became president. And so Madison wasn't really sort of like, oh, I don't want to claim credit for these because, like, I'm still a politician. I don't want this to come bite me in the ass or whatnot. And so he didn't claim credit for these. And so there was a dispute over 12 papers. Who wrote those 12 papers? And so in 1963, what these two authors did is they used sort of basic statistical methods to model the usage of high-frequency function words. So basically what they did is people have writing styles, right? So the way you do also, and, by, of, on, there, how you use these sort of words that don't really give content but are just sort of function words can tell you a lot about who wrote these papers. So if you compare the ones to the ones that, if you compared the ones that are disputed to the ones that we know the authors of, you can sort of get a sense of who might have written these papers. And so it turns out that these two academics basically confirmed that Madison was actually the one who wrote these 12 papers and not Hamilton, right? So why am I telling you this story, right? So authorship attribution, it's a large literature in text analysis. And if you think about it, it can be applied for national security intelligence purposes, right? So if you have a bunch of forum posts, or if you have sort of documents that are coming out and you want to know who's authoring these, right? Is it a known terrorist? Like, if it comes out and it's anonymous, how do we sort of attribute authorship to this? And so these are some of the methods that have already been developed and have a long literature that you can totally just use to apply to answer those questions. And so, as I mentioned before, I work at the Institute for Quantitative Social Science, and we're doing a lot of this work, this interesting work. And we have a website there if you want to check us out. And that's Gary King. He's the director of our institute. And so I want to talk about 4 recent projects using text analysis that might have national security intelligence applications, and hopefully that you'll find interesting. Right, so this is just a sampling of what you can do in this area. So the first paper by King, Pan, and Roberts is reverse engineering censorship in China. Right? So in China, when you go post on social media, sometimes you get censored. Right? So the government doesn't like you talking about things that they don't want you to talk about. And so the question that these authors were trying to answer is who gets censored, what gets censored in China, right? What can we systematically predict how the censorship system in China works? And this gets to sort of like leadership intentions, right? If we want to try to figure out what it is that's going on in the mindset of Chinese leaders, this would be a good way to do it. So how did they do it? So in China, unlike in the US, where sort of like it's Twitter, Instagram, and Facebook are the main ones, there are over 1,400 Chinese social media sites that are active. And that first picture there is a list of, it's a logo of a subset of them. And so what they're gonna do is they're gonna monitor all 1,400 sites over 6 months in 85 chosen content areas. And so what they're gonna do is they're gonna go to all these sites, they're gonna download the posts the instant they appear, and they're gonna keep checking each post until they figure out whether it's censored or not. And it's really easy to figure out if you're being censored. I don't know if you can see those last 2 pictures, but if you keep going to those posts, eventually you might get a 404 error. Basically, somebody took that offline, so you've been censored. And so with that, and you can do that, and they like used a lot of computers set up all around the world to keep checking all these. I think they eventually did over 13 million posts just checking them. And so you can figure out which posts were censored, and then you can use methods to figure out, well, what are the topics being censored, right? What areas are being censored? And they also did a second paper where they experimented, right? So they actually created social media accounts and wrote posts themselves and tried to sort of experiment to see what gets censored. And so technically you can do all this, right? You can read, well, technically you can read 11 million posts and figure out what gets censored and what's not. But you might not live that long, right? So this is where text analysis methods comes in. And so what did they figure out? They figured out that the censorship program actually targets collective action rather than criticism, right? So one thing you might think is, well, they just want to censor anything that's critical of the government. That's actually not true. They're just concerned about if you want to bring a bunch of people together for certain things, right? So if you said, hey, let's all go party at Tiananmen Square tomorrow, right? That's problematic. But if you said, I don't like the one-child policy in China, they're probably gonna let that go, right? So that's a unique insight that came out of this. Here's another one. Jihadi radicalization of Muslim clerics, right? So we all hear about clerics every day preaching jihad in the Middle East, but actually most of them don't, right? Only some of them do. And so we want to, this study tried to figure out, well, what is it that makes them preach jihad, and what is it that makes others not preach jihad? Right, so what are we going to do? So we're going to download a sample of Muslim clerics, and we're going to figure out sort of, we need a way to code sort of how jihadi a cleric is, right? And so what we're going to do is we're going to use methods to compare a cleric's writings to the writings of known jihadi activists, right? And we're going to figure out, we're going to try to score each cleric on the level of jihadi-ness in their writings. And you see here, those are the types of words that are being used. In the left is jihadi words, and in the right are sort of words that clerics use that aren't really sort of jihadi words. And then we're going to merge that with other data that we collect on clerics, right? So each of these clerics has websites, and their clerics are basically like academics. They post their sort of their CV, their sort of advisors, and sort of we can download all of that data. And what did we find here? So we found that clerics with weak educational networks and connections, they often use jihadi ideology to appeal to lay audiences, right? So if you're a cleric and you went to and you have a lot of connections, a lot of times these clerics are co-opted by the state, and so if you're part of that network, you're set for your career, right? But if you're an outsider, if you don't have those connections, how do you make a career as a cleric? Well, that's where you use sort of jihadi ideology to appeal to lay audiences to get your own following, right? So this was also sort of a unique study that gained some insight onto understanding what it is that sort of makes clerics preach jihad. Here's a third study, right? Can we predict crowd behavior? So this is really interesting, and I'm sure a lot of people here may be interested in this. Sort of, can we predict when a protest is going to happen, when a massive coup is going to happen, so when a cyber attack is going to happen? Can we predict any of this? So what did this study try to do, right? So they tried to scan over 300 web sources, so news, blogs, forums, and Twitter, and these are in 7 different languages, and we're just gonna look for mentions of any type of event, okay? And then here we're gonna use the NLP methods to code sort of what it is. Is there an event here? Who is involved? What was the time frame? And so we're gonna use a machine learning model to try to predict, sort of, given where we are today, can we predict the probability of a significant protest in the next 3 days? And this graphic was taken from the paper. This is a prediction of the Egyptian coup in 2013. And so on the y-axis is sort of your sort of what happened. So I don't know if we can see this, but basically that red spot in the middle was exactly when the coup happened, and sort of that was their prediction. So this is really interesting because prediction is really big, especially for national security purposes. I think the verdict is still out on whether or not predictions actually can be made with social media. There are a lot of papers that try to do this, and this is one of them. But I think this is a very active field for text analysis. And so the conclusion here is that massive online, so these are all public data sources, right? So if you can gather 300,000 different sources and you can parse them all out and use text analysis methods, there is a potential for predicting crowd behavior. And sort of the last one I want to highlight is sort of anti-Americanism in the Middle East, and we want to try to understand what it is that how do we characterize anti-Americanism, right? So what are we going to do? We're going to download a bunch of Twitter posts by keywords, and we're going to consider sort of different areas that people are talking about the U.S. And so we're going to use some simple text analysis methods to just sort of classify like what proportion of posts are pro-U.S. versus anti-U.S., right? And so in this study, they found that anti-Americanism is directed towards the impingement of the U.S. on other countries rather than sort of hating American society in general, right? So these are just sort of 4 really 4 studies that our institute has done. And so this is a very small subset of what could be done. And I think this is a very fascinating area to get into if you're interested. And we definitely need more people doing this type of stuff because it's really interesting. It mixes sort of technical know-how with sort of real-world questions, right? And so all these have a starting point, right? So all these text analyses, they all start somewhere. And so the question now is, how do we figure out where do we start, right? How do we define the set of texts that we want to analyze? And then once we define it, how do we go about it? How do we get these texts, right? And sort of how do we follow these conversations as they evolve, right? So if we're looking at Twitter data, people talk about Twitter, about issues on Twitter all the time, and they use different words all the time, and the conversation keeps evolving. And so there are three things that we need to do. We want to define, retrieve, and follow, right? So in some cases, it's really straightforward, right? So the Federalist Papers example, that hasn't changed in 300 years, right? 200 years. So, well, or if you want to look at the complete works of Shakespeare, which is also a famous example, that never changes. But in most cases, if we're looking at like Twitter, news articles, blogs, there's a lot out there, right? There's billions and billions of posts, and we can't possibly digest all that at once. So how do we do that? And so most often, and I'm sure you've run into this, you just use keyword searches, right? So I'm just going to type in a word to represent that topic that I'm interested in. Hopefully I'll download everything that is related, right? So people actually do this, right? So I don't know if you can see this, but this is taken from a redacted DHS, Department of Homeland Security Analyst desktop binder, right? So the DHS, their National Operations Center needs to monitor things that are going on all over in the country and all over the world. And they're going to use Twitter to do this. And so how do we monitor it? So they came up with this list of keywords, right? And this list rarely changes, right? So you can't really see the words here, but you can go and download this yourself. And so basically, it's a list of keywords that are pretty sort of general, and they're grouped by topic area. And so if you're an analyst, all you're going to do is you're going to take each keyword, and you're just going to type it into Twitter and see what comes up, right? So that's basically how the DHS is doing this nowadays. And so the point is, our analyses are only as good as our keywords, right? If we don't have the right keywords, we're going to miss a lot. So what's the technology for getting our relevant keywords, right? So that's our technology. Like, we sit here and we think about them, and we sort of use what we think we know to do these keywords. So here's an example, right? So I live in Boston, so one of the big things that happened was the Boston Marathon bombings. And so let's suppose you wanted to follow the conversation on Twitter about the Boston Marathon bombings, right? So you're going to think of keywords. So what would you think about, right? So these are a couple that come to mind, right? So Boston bombings hashtag was the biggest one. We're going to think about keywords about this event, right? But we also need to think about keywords about the suspects, right? So their suspects' names. What about the victims, right? So Collier was the MIT police officer who was shot during this whole episode. What about the reaction, right? Pray for Boston was another one. So what about the politics of it, right? So TCOT is top conservatives on Twitter. Benghazi, so a lot of people started tying in the Boston Marathon bombings with the Benghazi embassy attack, right? And so there's a lot about this topic in different sort of concept areas that sort of, if we want to analyze the Boston bombings on Twitter, we need to think about, right? So we ran an experiment on 43 Harvard undergrads. Basically, we asked them to think of how many, like exactly how you would do this search, right? So these are all the keywords they came up with, right? Most of them are pretty decent. Some of them are really weird, but and I don't know if you can see the color, but the ones in red are the ones that were thought of by only 1 out of 43 people. Okay, so 59% of them were suggested by only one, and it's not the same person. It's like one person thought of that word. So if you had 43 different analysts, you can come up with a decent set. But what if you were one analyst or two analysts? How many keywords would you be able to come up with? The median number was 7. Right? So 7 is pretty good, but it's not the complete set. So we're really good at sort of getting a small list of good keywords, and we're really good at recognizing a good keyword when we see it. But we're really bad at just recalling long lists of keywords. And so there are some methods out there to do this. So one is Google Adwords, right? So we're going to take your search queries. We're going to see what people are searching on and figure out what words are being used. We can go to a thesaurus. We can do something called co-occurrence methods. But sort of, we had a paper. So this is a paper that we wrote recently, which turned into Thresher now, to help with this problem. Right? So we're going to keep humans in the loop and help them find better words. So I'm going to skip a little bit of how it works. We have a paper if you want to, if you're interested. But let's think about some applications of this, right? So this example of Boston Marathon bombings on Twitter, right? So our tool tries to separate out the relevant words from the irrelevant words. So what are we going to do? So we're going to start with the hashtag Boston bombings. That's the one that we know. Okay, so we know this one word that's good, and we want to find a bunch of other words. And so S is just a larger set that we're going to search over. And so we're going to search over tweets about Boston in general. And so this is what we got back, right? So we have a list of like thousands of keywords, and we've separated out. So on the left are keywords that sort of are about the Boston bombings. And on the right are sort of words that people use when they tweet about Boston in general. And I don't know if you lived in Boston, but Boston's a huge sports town, right? So when they're not tweeting about the marathon bombings, they're almost always tweeting about sports. Right? So we can do these in different languages, right? So we tracked sort of the Bolshoi scandal, and so the Bolshoi scandal. Bolshoi was a high-ranking member of the Communist Party who had a bright future until scandal hit, and now he's in jail. And so here's some keywords that we tracked about this issue, right? So Wang Lijun is the police officer who started the entire scandal, and sort of we can see that we can find, if we were trying to follow this scandal on social media, like here are some words that we might use that we found, and I'm not sure if sitting down we would have found a lot of these words on our own. Right? Here's an interesting one. And so if we want to find out what words are being used to talk about suicide bombings in Arabic, right? So what we're going to do is we're going to start with the keyword martyrdom operations, which is suicide bombings. And we're going to search over this Jihadi web library. And so we found these keywords, right? So these look pretty, some of them look a little weird, right? Like what is Steed doing there? Boy. So boy is actually a story about the boy and the king, which is a relevant story to jihadis. And what about all these rest of these words? Well, this is pulled from the Quran, Quran 860. This is a verse that people use a lot to talk about suicide bombings. Here's another example, right? So Arabic is actually divided into a bunch of dialects, and most people use modern standard Arabic when they talk on social media. But a lot of people also use dialects, and sort of it's very hard to figure out like what dialect a post is coming from. And so we're trying to do this, and we're trying to figure out can we use keywords and Thresher to separate out dialects. And so we're beginning to experiment with this example, but we can see like we found sort of some words that are distinctive for each dialect based on our tool. And so there are these conversations that, as I said, they evolve really quickly. So just a couple final examples, right? So freedom in China, this word is censored, but people use the word I field to represent freedom, and it's because they're homographs. Like, so if you see those characters, they look almost exactly identical. So people will use the bottom one to substitute for the top one. And here, harmonious society, harmonious it was slang for like censorship, basically. And so the slang for censorship got censored. And so people use river crab because these two words actually sound the same in Chinese. And so that's a substitution. So we need to try to, when people do this, we need to follow this, right? And the last example, we were working with the DHS to sort of figure out the distribution of child pornography. And people use keywords, really like cryptic keywords, to denote when like they're offering child pornography. And so we need to find these because these change over time. And basically the DHS has no idea like to the extent to which people use these keywords. And so we're going to try to help them, right? So our tool basically is another application of text analysis that has really cool potential future applications. And if you're interested, so my website is there, our startup Thresher Ventures, and sort of stuff that we do at Harvard. Thank you.
Thank you, Patrick. So I want to start off with a question. In your predicting crowd behavior, how does that relate to epidemiological modeling, or does it at all?
Right. So that's interesting, right? So it uses a lot of the same methods. The question is sort of so there are issues of like, can we predict outbreaks of viruses using social media? So I think presumably like you can use some of the same methods to do basically anything, right? So I did predicting crowd behavior because that's of interest to the intelligence community. But you can use the exact same methods to predict like sort of if there's an outbreak of Ebola in some remote area of Africa, and sort of these like social media sources are reporting it, but like it's somewhere hidden on some corner of the web that we need to try to find, you can absolutely use these methods to sort of do that exact same thing. Right?
Questions from the audience? Yes, sir.
Is any of the work you do in machine learning relating to artificial neural networks?
So I would say artificial neural networks. That's sort of one of the methods of machine learning. Our work uses basically like whatever methods fit sort of the problem, and so neural networks, we don't specifically use that one in any of our work, but sort of that's not to say that we don't use it. We use similar methods to do that.
So the Chinese use the 50 centers and the Russians have troll bots. So can you use this technology to basically to identify those folks and separate the noise from the signal in terms of these keywords?
What? Can you repeat that question? What are you trying to
The
separate?
Chinese, they actually have a large number of people that they pay to actually get into these social media conversations to disrupt and make them chaotic.
Right.
And they add a lot of extra words and things like that. Russians, you have automated methods. So you have a lot to generate a lot of noise in the social media channels to disrupt the communications going on. Can you separate those out? Can we divide those out?
That's an interesting. I mean, we haven't tried it, but that's an interesting application, right? So how we would do this? We would need a sample of posts that we know are sort of made by these sort of Chinese government officials, like a small sample, and then from there we can try to go on to the larger forum networks and try to figure out, are there specific words that sort of these people are using that are sort of that separate themselves from sort of the normal conversational social media.
Last year they released somebody released a secret manual for these folks, and you know, it goes through a list of things that you need to do, and the last one is if all else fails, cause chaos. It's becoming the noise floor on these social media conversations is going up because of both automated methods, and the Chinese have plenty of people who also do these things. So
that's a really interesting application that we'll look for, and thank you for that suggestion.
What programming languages do you in machine learning, and are there any online resources related to machine learning that you recommend?
So the programming language that we primarily use is Python. So Python is pretty big for sort of, especially for sort of text analysis. That's what we use. We also use R sometimes. And both of these have huge communities out there. I wouldn't even begin to tell you like what are some good sources, because like you enter Python and you'll get on Google and you'll get like millions of hits. But there are things like, so if you're interested, Code Academy has sort of these short tutorials to get you started on Python. There's a Learning Python the Hard Way manual. That's how I learned it. And so if you just Google online, and there are a lot of resources like that.
Yes, sir.
It's interesting, working on a project where we're looking at controlled vocabularies for next generation learning, and it's just at its infant stage. So obviously, this has the analysis phase, but there may be a time where the controlled vocabulary can benefit the user and learner and actually help out, eliminate some of the noise that's out there, because the user community is not going to fall prey to certain things. So I was just wondering if you're seeing any crossover as far as maybe controlled vocabularies, verbs, nouns, and things that they're trying to use in next generation learning and text analysis, for example.
Right. So I think I'm not as familiar with that area, so I don't know the correct answer. Right. Yeah. So, but there are lots of crossovers. There are a lot of sort of text analysis is a huge field now, and so I wouldn't be surprised if there was.
On the predictive analysis of the crowds, it appears, because it's research, it appears as a look back, right?
Mm-hmm. Exactly.
But with all the different activities that have happened domestically, we don't even need to look outside this country for disruptions. Have you guys looked at any of these before they've happened and actually been able to predict behavior? Or did you look at any of them and not be able to predict it as well?
So I didn't personally do that work, so I can say I haven't, but I believe they have, and it's very very hard, basically. Like you can go back, you can always go back and say, yes, we were successful, but I do know that there are attempts, like there's sort of not domestically, but there are sort of state failure task force to sort of look at sort of, can we predict state failure and sort of things like that. And I think the answer to that is it hasn't been all that successful. That's not to say that we won't eventually get there. My personal opinion is that we'll never like be able to predict very well, but there are potentials to sort of assign probabilities to these things, and sort of, I think the potential in sort of Twitter and forum posts and news articles is sort of something that's untapped, and yeah, I think that's an open question, and I don't know if we have done it successfully beforehand yet.
I feel like there's a timing issue with that too, because like once it gets underway is when people are going to start like tweeting about it more and posting about it. So can you really predict it far in advance?
Right. So there's a limited time window, right? It's like when like what's the time between when there's an inkling of it and when it actually happens? That's probably only a couple days. And there's also the issue of, we as academics, we don't have sort of the real-time streaming of large amounts of data that sort of maybe other entities might have. So that's another challenge for academics themselves.
Yeah.
Does text analytics only really look at mainstream media, or do they also look at media that's used on like the deep web, like for instance something that you can access with Tor?
Right. So they try to look at as many sources as they can, right? So that predicted crowd behavior thing looked at 300,000 web sources, and this was collected by a company, Recorded Futures. And so they try to, people try to look at as many data sources as they can. Of course, it's harder to look into the deep web than it is to follow the New York Times, for example. So There are attempts. How successful it is to track all these, I don't really know. I don't know if anybody really ever knows, right? But the answer to your question is yes, we do. We do look at some.
So I know a few anonymization organizations say like pass whatever you're posting through Google Translate it into a few languages, and then pass it back to the original language to sort of anonymize your word usage, like you mentioned earlier. How do you account for that?
So we don't at the moment, but we are we're under the assumption that, and I think it's mostly true, that we just download the original language. So we don't, especially like on Twitter, for example, like I don't think they do that. So I don't think that's.
At this point, the individual's actually doing that, so they can erase any trace of it's them posting.
I see.
So like anonymous forums, like Silk Road or something, they would say they're wanting to buy, I don't know, some drugs or something, and they have a long written out post about what they want. They pass it to say if you're French, Spanish, Arabic, and then back to English.
I see. Interesting.
So it kind of erases
Yeah. We don't account for that at the moment. So that's an interesting idea that we need to think about. Thanks.
I'll ask the last question. Looking at the textual analysis for authorship, is it possible looking at, so we know there are individuals that use multiple online identities when posting to, let's say, Jihadi blogs or sites. Is it possible to use that analysis to identify that individual as those multiple identities? And secondly, can you use it to identify bots operating in those sites? Because now there's concern that some of these forums are using bots to boost up the conversation and create consensus.
Right. So I think the answer to that, both of those, is yes. So, for example, if we knew, if somebody has an official account that they post from, and then like 10 different unofficial accounts, that's exactly analogous to the Federalist Papers example, right? There are also things like we can group things. So suppose we had no information about an official account at all. We want to say, like, there are a bunch of authors and we want to figure out who's similar, right, without knowing anything about them. Machine learning has a lot of methods that sort of like group things into groups, right? So this is the clustering idea, right? So can we group people who write similarly and then figure out, are they the same person? Is it a bot? Like, we can do that as well. So basically it's two sort of areas of machine learning. One's called supervised learning and one's called unsupervised learning. And supervised is where we know something and we want to try to figure out, is this new thing close to this something that we know? Unsupervised is we don't know anything. Can we group things together based on that?
Great. Patrick, thank you very much.
Thank you.